So far, we have been discussing about multivariate function and more importantly, how to partially differentiate this function with respect to any of the independent variable. Now, sometimes you might need to partially differentiate a multivariate function more than once. And at this point, that's why we have to introduce the second order partial derivative. The second order partial derivative tells us that the first order partial derivative has been partially differentiated again with respect to any of the independent variables. So what are we saying next is, let's begin with what you need to know. The first thing you have to be familiar with is the second order partial derivative of the multivariate function z with respect to the independent variable x. So if z is equal to a function of x and y, clearly we agree that z sub x simply tells us the first order partial derivative of z with respect to x. And we stated that we have some more other notation we use to denote this, which include that z dx and f sub x. Now, if we are willing to differentiate z 2 times partially with respect to x, then at this point we need z subscript double x. In another word, this is the same as d squared z x squared. Or better still, you have f subscript double x. And this is the second order partial derivative of z with respect to x. Now what about y? Same thing applies to y. If we have the first order to be z sub y, that is z dy and f sub y, then the second order would be z sub y that squares z that y squared, or probably f sub y. So as the case might be, the choice is yours. Now, sometimes we might need to find the second order partial derivative in different way. What am I saying next sense? Consider the function z that is in the first place partially differentiated with respect to x. Now, what if we are willing to partially differentiate z sub x now with respect to y? What would happen? In this case, we would have z subscript xy. And what this tells us in essence is that the first order partial derivative, which has been differentiated with respect to x, is now being differentiated with respect to another independent variable y. We call this kind of partial differentiation, we call it a cross partial differentiation. The previous ones, which are similar, we call them a pure partial differentiation. So there might be something you want to be familiar with. So these are the basic things you just have to be familiar with by dealing with problems involving the second order partial derivative. So now, to get out the logic, how the process works, we'll consider it by using some examples. So just stay tuned and stay focused. Pay full attention to how I will be disclosing the process of finding the second order partial derivative of a multivariate function with respect to any of the independent variables. Let's start with example number 1. Consider the function z that is equal to 7x cubed plus 9xy plus 2y squared. So 2y to the power of 50. So if you have a question that requires us to find z sub x, z sub xx, z sub y, z sub yy, and z sub xy. Now, lest I forgot, keep in mind, either you are required to find z sub xy or z sub yx. It's only the process that is different. at the end of the day, you will end up having the same result. They both provide the same result in the end. So, regardless, you will end up with the same thing. So, just keep that in mind. But let's find both in this problem. Let's find the both and compare our results and see if what we are seeing actually tallies. So, we also want to find, so I'm getting rid of this and now, and include comma. Then let me try to shape this a little bit. And boom, perfect. So now we have and z sub y x. Perfect. So if you actually know what to do already, feel free to pause the video and try to provide the solution to these problems. Let's begin with z sub x. You know that already. So we are differentiating partially with respect to x. So let's pay attention to the terms that has x. And then let's move to the term with x and y. So this has x. Differentiating it, we have 7 multiplied by 3. X, reduce the 3 by 1 becomes 2. Then plus. Now just combine the coefficients and the opposite variable 9y. And then differentiate x. Derivative of x is simply 1. So we multiply with 1 plus. Now this will be considered as a constant. Hence becomes 0. Thus, z sub x would simply be equal to the product of 7 and 3 is simply 21. And we have 21x squared plus 9y. And that's simply z sub x. On to z sub y. Or let's just, I get rid of z sub x without finding z sub xx. So now z sub xx. To find z sub xx, all we need to do is to partially differentiate z sub x again, but also with respect to x. Keep in mind. So we are paying attention to 21x squared. Differentiating 21x squared again with respect to x, we have 21 multiplied by 2 multiplied by x. Reduce this 2 by 1, that's simply 1. Now 9y doesn't have any term associated with x. Hence, the derivative is simply 0. Thus, z subscript double x is simply 42. The product of 21 and 2 is 42 x. And that's our results. Have this class onto z sub y. So, what is z sub y? So let's pay attention with the terms that has y. So, starting with this, just pair 9 and x together. Okay, so we have 9x. Then multiply with the derivative of the variable y. Derivative of y is simply 1 plus, what is the derivative of 2y to the power of 5? That's simply 2 times 5 times y raised to the power of 5 minus 1 is simply 4. So reduce the index by 1. Thus, z sub y becomes 9x plus 20. Okay, that's not 25. 2 times 5 is 10. 10y to the power of 4. And that's z sub y. So this becomes 0 as it is a constant. Now for z sub double y, that gives us, let's differentiate this partially again with respect to y. This doesn't have y. Hence, it becomes 0 plus derivative of 10y to the power of 4 is 10 times 4 times y. Now reduce the 4 by 1 gives you 3. Thus, we have 10 times 4 is 14 y to the power of 3. So this is z subscript double y. So I hope that's clear. Now on to z subscript xy. So we are finding the both and then compare our result. So earlier, well, I can't really recall, but let's just find it. We said z sub x, okay, we can just write it straightforward, would be 9y, okay, 21 over 21 x squared plus 9y. This is our z sub x. Now let's differentiate z sub x partially with respect to y. Pay attention to this. There's no y terms here, okay? Thus, the result will be 9. Okay? Now this will now be considered as a constant while we pay attention to this, as it is a related term with y. And the derivative of 9y with respect to y is simply 9. Excellent. Now let's have this in yellow. What is z sub y? Z sub y would simply pay attention to the terms with y, which is this. So that will be 9x plus, if we differentiate this with respect to y, earlier we got this to be 10 y to the power 4. Is that taken? Perfect. Now we want to differentiate z sub y partially again, but now with respect to x. Since this doesn't have x term, then we consider that as a constant. And since the derivative of a constant is 0, we can ignore it and pay attention to 9x alone. But the derivative of 9x with respect to x is simply 9. Well, by comparing our results, we can clearly see that they are the same. Thus, z sub xy would always be equal to z sub yx. And that's our solution to this problem. So I hope you find this helpful. On to example number 2. So consider the function z, and have that on white, that is equal to x cos y minus y cos x. So feel free to pause the video and figure this out yourself. The question asks us to find z sub x, z subscript double x, z sub y, z subscript double y, z subscript x, y, and z subscript y, x. So let's begin. For the first one, z subscript x. So let's differentiate this function partially with respect to x. Okay. Now remember, we can't use product here because it's a partial differentiation. So cos y will be considered as a constant. Is that the case? Y here also will be considered a constant. So if that is the case, if we have it in differentiating this with respect to x, taking cos y as a constant, so we have cos y times the derivative of x is simply 1, the minus. Now let's take this as a constant, y minus y times the derivative of cosine x is negative sine x. Please, am I communicating? Yes, normally if it is x cos x, we would have used the product rule, but this is a partial differentiation. Cos y must be treated as a constant. Am I communicating? Thus, this is the right solution. So if we simplify to the list form, we should have cos y then minus times plus. That will be positive. So we have plus y sine x. So this is z sub x. Now for z subscript xx. So now we want to differentiate again with respect to x. Since there is no x term here, we consider it as a constant. And since the derivative, since the derivative of a constant is 0, so we have 0 plus. Now pay attention to this. Remember, we are still differentiating with respect to x. So y must still be considered as a constant. So it's multiplying. The derivative of sine x is cosine x. Thus, we have z subscript double x to the y cosine x. This gives us our solution to z subscript xx. Now let's pay attention to z sub y, z subscript double y. So for z sub y, we are differentiating this multivariate function partially with respect to y. So this is a constant, this is a constant. So if we take it and then connect it with a product, the derivative of cosine y is simply negative sine y, the minus. This, we are differentiating it. Let's have cosine x first. Multiply by the derivative of y is simply 1. Derivative of y with respect to y, okay, is simply 1. So that gives us negative x sine y by the time we multiply, the minus cosine x. Excellent. So that's z sub y. What about z sub yy? So let's do that again. We are still differentiating partially with respect to y. So this must still be held as a constant. So we have negative x multiplied by the derivative of sine y gives us back cosine y. Excellent. The minus. Now this is a function of x, but we are differentiating with respect to y. Thus, this will also consider as a constant, and it will be 0. Final answer becomes minus x cosine y. Let me write that properly. So this is our z subscript yy. Now let's find the cross partial derivative. Remember, they are called the cross partial derivative. Sometimes you might just have a problem now. We said find the cross partial derivative. Some we said find the pure. So when they said find the pure, then it is z sub xx and z sub yy. When they said find the cross, z sub xy or z sub yx, you can find the two of them. Depends on the difference. And find one of them, since they will yield the same results, so you should be on the good side. Now let's find them. So now z subscript xy. Okay, we need to find x first. Earlier we actually said that z subscript x is cosine y plus y sine x. Yeah, I can recall that vividly. So now we can get z subscript xy. So we are differentiating this partially with respect to y. Derivative of cosine y is negative sine y plus this will be held as a constant. Derivative of y is simply 1, and thus we have sine x. So this is simply negative sine y. Or let's just rearrange and have things in the proper way. That's sine x minus sine y. So that's z subscript xy. So I don't need to show this out. However, you can try finding z subscript yx, or let's find it anyway for those who might be very, very curious. So z sub y, I have to find that again. I can't really remember what we said it is. So z sub y, we are differentiating with respect to y, so that gives us x minus sine y. I differentiate cosine y, I have negative sine y, multiply with x as a constant, then we have minus, okay, let me get rid of this bar, yes, minus, this is a constant, sorry, this is a function, this is a constant, so we have cos x. Excellent. Now let's differentiate with respect to y, so with respect to x partially, so we have z sub yx. So z sub yx now we are differentiating with respect to x partially will simply be equal. Now take this as a constant, we have minus sine y multiplied by x is what? Derivative of x with respect to x is 1, then minus. Derivative of cosine x is what? Is negative sine x. Perfect. Now if we do this math, we should end up with minus sine y, okay, then plus sine of x. And if we rearrange again, we should end up with, let me just say that this, we have it in red, sine x minus sine of y. Does that correspond to this? Yes, it does. Thus, our answer is the same. So, guys, this is how you can easily find the second order partial derivative of any motivated function with respect to any of the independent variables, either for the pure or for the cross. Now, for better understanding, let's consider one more example problem. By the way, if you are yet to subscribe to this channel, please feel free to subscribe. Also, if you are enjoying the video, can you leave a like? And as I will tell you to recommend it to many audience, as people actually find it interesting. On to example number 3. Consider the function v, that is a motivated function, which is equal to the natural log of x squared plus y all squared. So the problem asks us to show that di squared v by di x squared plus di squared v by di y squared is equal to 0. So the problem with what we are required to find doesn't in any way ask us to find the cross partial derivative. But we want to find it. Let's find it because we want to know what it is. And then we can now answer what the problem wants us to do. So we are finding v sub x, v sub xx. Now remember, v sub xx. I just like using this kind of notation. It's much more simpler, as we always want something simpler for you, understand? And I find it very convenient to using it. So v sub xx, v sub y, v sub yy, what else? V sub xy, and v sub yx. So I will do v sub xy. So I want you to do v sub yx. Then tell me in the comments if you end up with the same thing as whatever I got in v sub xy. Okay, so let's begin. V sub x. How do we partially differentiate this function with respect to x? Well, let's set this to something else. Let u be equal to x squared plus y squared. Thus, v will become len u. Is that again? Perfect. Now we can find the v that u, right? The partial derivative of v with respect to u. The v that u, remember, this is natural law. The result is simply 1 over u. Excellent. So let's keep that. This is what we need. That's enough. Now we can come back to v sub x. Remember, v sub x is the same thing as di v by x. Okay, so let's be realistic. If we have the product of di v, di u, and the product of di u, di x, can you tell me what it will be? Clearly, it should be this. That should be di v, di x. Thus, that's what we are about doing. Since we have di v, di u, and we have u to be this, we can always differentiate partially the function u with respect to x. Do the product and get about the result. So that's what we are going to do. So let's get to this one. So we have di v, di x to be equal to okay, let me just write it. Let me write it so that you won't get confused. Di v, di u multiplied by di u, di x. So now, di v, di u, we've got that to be 1 over u. What will be di u, di x? Differentiating u partially with respect to x, simply 2x. This is a constant, y squared, and it becomes 0. So multiply by 2x. Thus, final answer should be 2x divided by, now instead of u, I'll put this, because all our answers must be back in terms of what we are given, x squared plus y squared. Perfect. We got the v sub x. Now v sub xx. To find v sub xx, we actually need to use the quotient rule of partial derivative. Yeah, because this is a function at the top and this is another function at the bottom. Okay, fine. V sub xx. The quotient rule of partial derivative says that when you have the product and the quotient of two functions, where the functions are multivariate function, f sub x, y. I have the video already. I will leave the link. Divided by g sub x, y. Just want to show you the concept. Then the partial derivative of the function with respect to x. The partial derivative of the function with respect to x. Let me get to the first one first. If this is z, okay, if the function is like this, that's z, then z sub x, then z subscript x, please pay attention, z subscript x would be, just like the product of the usual differentiation, our normal derivative, right? It's just like the usual formula. But remember, everything will be with respect to what you are partially differentiating to. So it will be the bottom function, g sub x, y, multiplied by the partial derivative of the top one, but it must be with respect to x, f sub x. Now remember, it is minus sign that is connecting them. Minus the top function f of x comma y. So let me squeeze that there, times g sub x. Then you divide it by the square of g of x comma y. So that's it. Am I communicating? So this is what we are going to do. This is what we are going to do to get v subscript xx. Am I communicating? This is what we are going to get v subscript xx. So let me get rid of this one. Just want to okay, perfect. Remember, this is v sub x. V sub x. Now v sub xx, 2x is our, you can excuse me, 2x can be seen as f of x comma y. Then x squared plus y squared can be seen as g of x comma y. So that will be equal to g of x comma y. This is this one. So we have, is the red comment, is he perfect enough? Let me use y. Let me use y. It's to me it's just somehow blurry. So we have x squared, let me put it in bracket, plus y squared. Then multiply by, I have to shift it a little bit because it will be a little bit longer. Let me adjust it down. Okay, perfect. Multiply by, now f subscript x, we are differentiating 2x with respect to x. That will just be 2 times 2. Excellent. Minus f of x comma y, that's just 2x multiplied by g subscript x. So we are differentiating x squared plus 2y, plus y squared. We are differentiating it partially with respect to x. That will be 2x also times 2x. Please, are you following? G of x comma y is this one. If you partially differentiate this function x squared plus y squared partially with respect to x, you would get 2x. Excellent. Now we have to be divided by the square of g of x comma y, which is x squared plus y squared all squared. Is that okay? Perfect. So now this becomes 2 times x squared plus y squared, okay, minus 2x times 2x. That will be 4x squared, okay, and then this can go at this point. We divide it by the square of this one, x squared plus y squared all squared. Excellent. Okay, now can we do another thing? Let's expand this one and see if we can actually simplify a little bit more forward. Now this can go also. So now if we expand this, we should have 2x squared plus 2y squared minus 4x squared divided by x squared plus y squared all squared. Now this can reduce actually 2x squared minus 4x squared. That gives us our final answer to be 2y squared minus 2x squared then divided by x squared plus y squared all squared. Okay, perfect. We can factor out 2 here. Excellent. Thus, we can have 2 in a bracket of y squared minus x squared and divided by x squared plus y squared all squared. Okay, perfect. Well, this should be the end. I was thinking if the x squared and other can cancel, but they can't, because even if we factor out the minus sign from the top, this becomes minus again, and I won't be able to cancel. So this is our final answer. This is v sub xx. So we have to note it down. We have to note it down. Okay, just have it noted down. V sub xx. So our v sub xx is what we have right here. So now let's pay attention to v sub yy and v sub y. So this can go. For v sub y, what would that be? So remember, we are still differentiating partially with respect to y. So it means we would need that v, that would be that v that y. So that v that y will be equal to that v that u multiplied by that u that y. So that v that u, we got that already, 1 over u. Now let's find that u that y too. From here, what would that be? That would be 2y. Perfect, that would be 2y, you understand? When you partially differentiate this with respect to y, you get 2y. Excellent. So we have v sub y should be, so the v that u, that's 1 over u multiplied by 2y. Thus, that would be 2y divided by our u is x squared plus y squared. Again, v sub yy. Remember, we are still using the quotient rule of partial derivative. So let this be our f of x comma y, and let this be our g of x comma y. So to get v sub yy, we know that according to the quotient rule of partial derivative, that will be g of x comma y times f sub y. Now you are differentiating partially with respect to y, not f sub x again, just as the way we did it in the previous chapter. The minus f of x comma y multiplied by what? G sub y. Thank you. Divided by, I hope you are following. Excellent. Divided by the square of g of x comma y. Perfect. So let's do the maths. G of x comma y is still our x squared plus y squared. Now f sub y, if you differentiate 2y, you should get 2. The minus f of x comma y is 2y, then times derivative of g, and the derivative of g of x comma y partially with respect to y is simply 2y. Are we there? This is g of x comma y, x squared plus y squared. If you differentiate it partially with respect to y, ignore x squared, you have y squared, and you differentiate y squared, you should have 2y, and that's how we got the 2y. Am I communicating? Perfect. Then we still have a division of, now g of x comma y is simply x squared plus y squared all squared. Perfect. We're moving forward. So this can go now. This can also go. Those are our, okay, don't forget this is v of xx. That's why v of yy. Bye. V of yy. So v of yy now is now equals to, just like the way we did earlier, let's expand. See, 2x squared plus 2y squared minus, when you multiply this, you should have 4y squared divided by x squared plus y squared all squared. Now v sub yy should be 2x squared plus 2y squared. That's, so we can't add that actually, but this can actually be addable. So that should be 2x squared minus 2y squared divided by x squared plus y squared all squared. Excellent. So we have that. We have v sub yy also. So let's add it to what we got in v sub xx. Since we got v sub xx, we got v sub xx to be equal to 2y squared minus 2x squared divided by the same denominator, x squared plus y squared all squared. So let's add them. So adding them, we must end up with 0. That must be 0. Should that be 0? It should be 0 from this and this. So let's add them. So v sub xx or v sub yy, regardless, plus v sub xx will becomes 2x squared minus 2y squared. Now the denominator are the same, you can take 1. Then plus 2y squared minus 2x squared divided by x squared plus y squared all squared. Now this cancels. this also cancels. That's 0. 0 by that gives us 0. So that's how I solve. Thus, we have actually done the right thing. So that's how you can easily solve this problem. Please, I want to believe by now you should have been elevating your understanding in the second order partial derivative. Now on to v sub x, y, and v sub yx. So let's look into that. So like I said, I will do v sub xy. Is that what I said? Let me just do one and do the other one. So to find v sub xy, I actually need v sub x first. Well, can I remember what we said v sub? Yes, I can. V sub x we said is equal to 2x by x squared plus y squared. Vividly, this is what we said it is. Why we got v sub y to be 2y and that. Perfect. Now, how can I differentiate partial v sub x now with respect to y? What can I do? Now, you might, what do you think first? Let me direct the question to you. What do you think we can do v sub xy? Well, so I don't know what is actually coming to your mind, but we are not using the quotient of partial derivative. We are not. Yes, because the upper function is not a function of y. Am I communicating? It is not a function of y. So we must see it as a constant because we are differentiating partially with respect to y. Am I communicating? We are differentiating partially with respect to y. The reason why we have been using quotient 2 earlier is all because when we want to find v sub x now, please look at the board. I've written 1x beside this v sub x in yellow. V sub x is now. Consider the upper function is a function of x. The lower function is a function of x and y. So we have two multivariate functions. That's why we use the quotient of partial derivative. But now we want to find the derivative with respect to y. The upper function has no business with y. So it's a constant. So thus we are not using quotient 2. So let me take it out. 2x times 1 over x squared plus y squared. Now I want to differentiate this thing with respect to y. What can I do? What can I do? This is what I can actually suggest. Let's look at the math. Okay, if we said v sub x is v x. Okay, perfect. Then I want to find v sub xy. Remember, v sub xy is v x y. Excellent. So basically, what I want to do is that I want to set this thing to be equal to u. That will help me to be able to differentiate partially with respect to y. If u is x squared plus y squared, now I will have v sub x. I will have v sub x now. This is not v sub xy. We have not differentiated. So we have not differentiated partially with respect to y yet. It's just v sub x as it is. Excuse me. So I will now have my v sub x to be 2x times 1 over u. Now, I can easily find v sub xu, which is the same thing as v x u. Because 2x will be considered as a constant, and the derivative of 1 over u with respect to u is ln u. That will be 2x ln u. Perfect. Perfect. Now, let's look at this realistically. Let's look at this. If I do v x u times u y, what will be this math? What will it be equal to? Well, clearly, we can set this cancels. And thus, we can have v x y, which is actually what we are looking for. But these two can actually be gotten with what we have already provided. So, that's excellent. Let's do that. Please, I will get that. Perfect. So now, we basically want to find, okay, we have v x u already. That's 2x ln u then we are multiplying it with di u di y. So di u di y, u is equal to x squared plus y squared. If we differentiate with respect to y, that should be 2y. And if we proceed forward, we should have 2x times 2y should gives us 4xy ln u. But we don't want u. The question is not given to us in terms of u. We need it in terms of what is given to us. Thus, final answer would be v sub xy to be equal to 4xy ln x squared plus y squared. And that's our v sub xy. So find v sub y at x and tell me if you end up with the same result. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now.